Now I will discuss about the Paul's exclusion principle. According to the Paul's exclusion principle, no two electron in an atom having same four quantum number. No two electron in an atom having same four quantum number. Let me explain with an example. This is your secondary statement. Now I will discuss about the explanation. Before going to explanation, I want to say something about the daily life example. If you think about any two persons in our society, then the two persons are not identical with each other. They have some different set of address. Maybe the name will be different. Maybe the name of the father will be different. Maybe they are different in their shape, different in their size, different in their characteristic. Maybe they belong to different country, different state, like this. We know that in an atom there are many number of electrons are present, and each electron must have a fixed address, that is must have a fixed set of quantum number. If the three quantum numbers are same, there must be the fourth quantum number must be different. Suppose I will take two electron in an atom, and the two electron must be belongs to suppose K cell. Must be belongs to suppose K cell. And these two electrons are named as E1 and another is E2. Then what are the four quantum numbers for E1 and four quantum number for E2? If you think about the principal quantum number of E1, then it must be equal to 1 because the E1 present in the K cell. For E2, the principal quantum number N is also 1 because E2 also belongs to K cell. We know that for N is equal to 1, L is equal to 0. Here also L is equal to 0 for E2. If L is equal to 0, M is equal to also 0 for E1, and M is equal to also 0 for E2. Now I will want to write the S value, that is your spin quantum number. We know that in an orbital there are two electrons are present, and the two electrons must be spin in opposite direction. They do not spin with the same direction. If one electron spin in clockwise direction, then the other electron must be spin in anti-clockwise for the stability of an atom, for the stability of an orbital, for the stability of an cell, for the stability of an subcell. In K cell, we know that only one subcell is present, and the subcell having also one orbital. And in K cell, we know that two electrons are present, and the two electrons must be present in the S orbitals. That means K cell having two electrons, and the two electrons must be present in one orbital, that is your S orbital. In S orbital, if one electron spin in clockwise direction, other electron must be spin in anti-clockwise direction. Otherwise, the stability of atom is lost. Suppose suppose the electron E1 spin in clockwise direction, so it is bound to give S is equal to plus R. Then we cannot give S is equal to plus R to the electron E2 because the E1 electron spin in clockwise direction and E2 must be spin in anti-clockwise direction because the two electrons are present in one orbital of a cell. If E1 is your minus half, E2 must be your plus half. You cannot write here also minus half, or you cannot write plus. This is your plus. If you will take S is equal to plus half for E1 electron, then it is bound to take S is equal to minus half or E2 electrons. Suppose you take another 2 electrons. One electron belongs to K cell, another electron belongs to L cell. For E1 n is equal to 1 because it belongs to K cell. For E2 n is equal to 2 because it belongs to L cell. Like that, if you think about the E1, the L value is your 0. For E2, the L value is your 0, 1. If L is equal to 0, M must be 0. If L is equal to 0 here, then M is equal to 0. If L is equal to 1, M is equal to plus 1, minus 1, 0, like this. Many set of quantum number will be produced. S is equal to maybe plus half or maybe minus half, because these two electrons are present in a particular orbital. So you can take plus half or minus half. Here you will also take S is equal to plus half or minus half. If the two electrons are present in one orbital, then it is bound to give one is your plus half, another is your minus half. If the two electrons are belongs to in different orbitals, you can take S is equal to plus half or minus half. If it is your plus half, it is not bound to write minus half for these electrons. After looking the two examples, it is seen that the 4 quantum numbers for any 2 electron cannot be same. Look at that in the first example. The 2 electron having same n value, same l value, same m value, but they are different in their s value. The fourth quantum number is different. In this case, the initial principal quantum number is different because they belongs to different cells. From the data, it is clear that no 2 electron in an atom having same 4 quantum number. Maybe highest 3 quantum number will be same, but the 4th quantum number must be different. Particularly from this data, it is clear that an orbital having maximum 2 electrons. That means Pauli's exclusion also stated that an orbital having maximum 2 electrons. That is the second statement of Pauli's exclusion principle. What are the conclusions derived from this principle? This principle said that an orbital having maximum 2 electrons. By this principle, we can able to calculate the number of orbital present in a subcell, number of electron present in a subcell, like that. We can also calculate number of electron in a cell, number of orbital in a cell, by the help of Pauli's exclusion principle. Next is your conclusion. It helps to calculate the number of electron in a subcell. We know that suppose I will take S subcell. We know that S subcell having one orbital, that is your S, and each orbital having maximum 2 electrons. Here the number of orbital is your 1. So the number of electron in that orbital is 1 into, that is your 2. Similarly, take P subcell. The number of orbital in p subcell is your 3, and we know that each subcell having 2 electrons. That means the total number of electrons in p subcell is equal to 3 into 2, that is your 6. Similarly, we take S subcell, the number of orbital in similarly we take the D subcell, the number of orbital in D subcell is your 5. So the number of electron in D subcell is your 5 into 2, that is your 10. Like that, we can also think about F subcell. The number of orbital in F subcell is your 7. Each orbital having 2 electrons. That means the total number of electron in P is the total number of electron in F subcell is your 7 into 2, that is your 14. Like that, we also calculate the number of electrons in a cell by the help of Pauli's exclusion principle. Suppose think about K cell. Suppose think about K cell. K cell having orbital, that is your number of orbital is your 1. So the number of total electron in K cell is your 1 into 2, that is your 2. Think about L cell. L cell having 2 subcell, that is your S, another is your P. S orbital, S subcell having S orbital, P subcell having 3 orbital px, py, pz. The total number of orbital in L cell is your 4. As a result, the number of electron in L cell is your 2 into 4, that is your 8. Similarly, if you think about M cell having 3 subcell, one is your S, another is P, another is your D. S having 1 orbital, P having 3 orbital, D having 5 orbital. The total orbital is your 9. That means for M cell we can write the number of orbital is your 9. Number of electron in M cell is your 9 into 2, that is your 18. Look at that. For K cell we know that n is equal to 1. For L cell n is equal to 2. For M cell n is equal to 3. Now, if I will take the square of this, then there is your 3 square, that is your 9, which is equal to the number of orbital. Here, if you take the n square, that is your 2 square, that is your 4, which is also equal to this. Here, if you take the square, that is your 1 square, that is your 1, and it is equal to this. That means the number of orbitals in a cell is equal to n square, when n is the principal quantum number. So we can write direct formula, that is your n square. The number of orbitals in a cell equal to n square. If the number of orbitals in a cell is equal to n square, we know that each cell having 2 electrons. That means the total number of electrons in a cell is equal to 2 into n square, that is your 2n square. So we think about the 2n square rule. An important point, why Pauli's principle is called Pauli's exclusion principle. Why? Because it excluded the 3-4 electrons. It always take maximum 2 electrons. It do not carry 3 electron, 4 electron. It excluded more than 2 electrons. That's why Pauli's principle is called Pauli's exclusion principle.